Good morning, class. This is Mr. Eggleston, and this is lesson 6.7, square root and root functions. This is for Algebra 1. The learning targets are to understand square roots, cube roots, and the overall nth root as operators, as that undo squares, cubes, and nth powers respectively. They are inverses of squaring and cubing and raising anything to the nth power. We're also going to learn what the graph of the parent function of y equals square root of x looks like, and we're going to be able to describe its key features, including domain, range, and intercepts. All right, alrighty, let's begin. Use the grid paper on the right to draw a square with a side length of 3 units. So you're supposed to come over here and 1, 2, 3, I'll put it here, 1, 2, 3 here, so it's going to be this. That is a square of side 3 units, all right? What is the area of the square? If you count up the area, it's 9. There's 9 little squares in there. So it is 9. All right, sketch a square with the following areas on the grid paper, then identify the side length of each square. 25 square units. I'm just going to go up here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the square is going to be this. Okay, and there is 25 in there, and it's 5 by 5, a square is 5 by 5, all right? 36 square units. I'll just go over here to the upper right and go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and we have this. And that's a square of side 6 with 36 square units inside, because you can count them all up, it's 36. All right, and then they ask you for 9. 81. So that's going to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. A square of this size. Okay, and that's going to be 9 by 9, which is 81 square units. And I forgot to do the 49 square units, which would be 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So this is going to be right there. 1, 2, 3, 4, 5, 6, 7. So let me use a different color so you can discern. This blue is a square that has an area of 49 square units. And it's the blue one, that's 49. All right, notice that this is a 7 by 7 square. So let's see. And then identify the side length of each square. So 25 square units has a side length of 5. 36 square units has a side length of 6. 49 square units has a side length of 7. It's the blue square. And 81 square units has a side length of 9. Okay, and describe what a square with an area of 30 square units would look like. Okay, it would be approximately 5.5 units per for the side length. Okay. If it had side length, let me change color just so. If it had side lengths of 5, of 5 units, it would have an area of 36 square units. And at 5 would be 25. My bad. I was kind of projecting there, knowing what was coming. Of 25 square units, and if it had a side length of 6 units, it would have an area of 36 square units. Okay. Note 5.5 is halfway between the two. Between 5 and 6. Okay. And as you can see, 30 is roughly halfway between 25 and 36, roughly. Okay. Says use your work in questions 1 through 3 to plot points on the graph so that X is the area of the square. So this is the area. And the side length is Y. So this is the side length. Okay. So we have points starting with an area of 9, which is a side length of 3. And you got to be careful here. 9 is about halfway between 0 and 20. It's 10, so 9 is just a little bit to the right. So it'll be roughly right there. And then the next one, and that's that point there is area of 9 and side length of 3. Notice this is 2, so that's 3. There's 5 there. There's 7 there. Halfway between is the odds, 9 and 1. All right, 25 square units. Here's 20, 40, 30's in the middle. Halfway is 25. So 25 is at 5. So 25 is right there. Okay. And then the next one is an area of 36 with a side length of 6. So 36, here's 30, 35 is there. 36 is just to the left, right of it. And it's at 6, so it's there. All right. That's 6. Okay. And then the next one is 49, which is about halfway between, it's about 50. And we're up here at 7, which is halfway there. So 50 would be about there. 49 would be about there. Okay. And then lastly, 81, which is just a little bit to the right, is 9. And 9 is midway. So 81 is just right about there. Okay. So it looks like, and then at 0, we have 0 side length. So it looks like we have a graph that looks like this. Okay. Describe the shape. It starts at 0, 0. That's important to remember. 0, 0 is the starting point. Okay? And curves upwards to the right. To the right. Which is the positive positive x values. Okay. Does doubling the area of a square double the side length? No. It does not. Okay. The graph grows fast. Okay. The graph grows fast at the beginning, right? You can see it here. It's going up fast and then starts to slow down in its growth as we get to larger values of x. So it grows fast at first. And then more slowly, and then more slowly, as the side length, okay, and then more slowly. The side length won't grow as fast as the area. Okay. All right, let's go back and fill in some information about what the graph looks like. This graph that you see here is the square root function. Okay, y equals the square root of x. That's what the graph looks like. Okay. Notice at the beginning, this is more steep. And then towards the end, this is less steep. It slows down on how fast it grows. Okay? So more steep, so it's steeper at the beginning. This is definitely not a linear function, okay? And then it's less steep later on, okay? And also important, starts at 0, 0. This is our clue on how to graph these, knowing where the starting point is. It's at 0, 0. Then you're going to start to see, as we do this, how the graph will move around. The shape will not change, but the starting point will. All right? So also, as x increases, the graph grows more slowly. It slows down. Okay, and so over here, what we have is that over here, side length 3 units, that means the square root of 9 equals 3, but 9 is 3 squared, so the square root of 3 squared equals 3, and that's 3 to the first. So you see the square root undoes the squaring. They cancel out. They are inverses. Okay? Square roots and squaring are inverses. So this is y equals the square root of x. Okay? And what we were doing was taking the square root of each when we were drawing these squares to find the side length. Okay? And there you go. All right. Now, here are the basic quick notes. The first thing is to know that square roots and nth roots undo exponents. We are only looking at square roots right now. Algebra 2, we look at nth roots. But basically, and you'll see we'll look at the graph of nth roots in Algebra 2, but you'll look at that the cube root undoes cubing. The square root undoes squaring. So, examples, you know that the square root of 25 is 5. Well, you can also say the cube root. And notice how we write it. If it's not a square root, we put the root number, what kind of root, up here in the upper left corner. This is a cube root. So the cube root of 8 is equal to the cube root of 2 to the third, because that's what 8 is, and that equals 3. It undoes cubing. So the nth root of a to the nth equals a. Okay? This should have been nth root of a to the nth. I just realized that they did not have that. Okay, the graph of the square root function. We're not going to look at the nth root. We're just going to look at the graph of the square root. Looks like this. Okay. Just like we saw when we graphed the activity, right? It curves and flans out as we go further out, but it's always going up. It starts at the origin, 0, 0. The domain is all x greater than or equal to 0, and the range is all y greater than or equal to 0. Okay? Notice, you will never have a negative underneath the radical. Why? Because you can't take a square root of a negative. Try it on your calculator. You'll see it yells at you. It says, probably it'll say not real. It could say domain error is probably the most common, because a negative number is not part of the domain of the square root. And that's easy to understand if you just think about what the square root does. It undoes squaring. So if you think about this, square root of 4 is 2. Why? Because 2 times 2 is 4. But if you ask for the square root of negative 4, there's no number, right? Because what number, when you multiply against itself, will give you negative, right? It'll either, because we know a negative, not real. Okay? Because a negative times a negative equals a positive. So there's no way to take a square root of a negative number, because there's no number that you multiply against itself, positive or negative, that will come out negative. All right? The graph of the square root function, the parent graph is just y equals square root of x, which looks like this, right? Just remember that you basically will find the starting point. You can go over 1. What's the square root of 1 is 1. You go up 1. We go over 1, 2, 3, 4. Square root of 4 is 2. We go up 2, and so forth. Okay? If we went over 3, we're going to start getting into ugly decimals. All right? We'll go over this in class a lot. To move a square root function around, it will be of this form here. This is key. This is muy importante. All right? The y equals the square root of x minus h on the inside. Notice that's the end of the square root. On the outside, they'll have a number added. If it's x minus a number, it moves the graph h units to the right and k units up. Okay? And the graph will start at hk. Now remember, This is what's hard for students. Your x's are liars. Are liars. Notice it's x minus h. So if the number's holding hands with the x inside the house, like this is, you have to take the opposite. So, por ejemplo, if you had y equals the square root of x minus 2 plus 3, the starting value where you begin the graph will be at 2, 3. Notice, it's the opposite of that. And if you had that's the wrong one. If you had y equals the square root of x plus 4 minus 2, the starting point will be at -4, -2. Your x's are liars. Do not forget that. That's how you can easily graph this. You'll see that I always try to show you, instead of just randomly making tables, you can be smart and count. That's what I've always done with these graphs. So anyway, that's it. And then I'll come back and do the CYU. Have a good day.